Welcome back for another 6 Caillou challenge. This one's called Collatz. I apologize if I pronounce that wrong. A Collatz sequence starting with a positive integer n is found by repeatedly applying the following function to n until n equals 1. So you can imagine this process takes a larger integral value and will eventually work its way down to 1. And so you sort of have two cases. This is the function, right? And they have different functions to run depending on if n is even or odd. If it's even, divided by 2. If n is odd, multiplied by 3 and add 1. They got reference if you want more reading on it. We are creating this Collatz method here, and they're going to give you a positive integer. This is how they want it returned. So you can imagine this is a sequence, and they literally want arrow symbols between each iteration, each sequence value, starting from the first value and proceeding all the way to n, however many values get generated. So let's look at some examples to make this clear. Consider the input 4. So it's even, right? So you run that first function, n over 2. You print 4, you know, that is part of the sequence, and then you follow it with this arrow, which is a hyphen followed by a greater than symbol. And then 4 divided by 2 is 2. 2 is also even, so you divide that by 2 and you get to 1. Hopefully that's clear. Input 3 is a little better because you get to see an odd example as well. You start with 3. Of course, that's not even, so you have to run 3 times n plus 1, so that would be 3 times 3 is 9 plus 1 is 10. That's how we got here. 10 is even, divide by 2, you get down to 5. 5's odd again, so triplet, and add 1 gets you to 16. Divide by 2 gets you to 8, and then we've seen the 4, 2, 1 sequence, and you end at 1 again. Don't worry about invalid input. Arguments passed into the function are guaranteed to be valid integers greater than or equal to 1. So I'll leave that to you if you want to error check that. I won't here. And you can do this. Go ahead and pause the video. Come on back when you're ready and we'll go over solutions together. I'll do a couple. We did a challenge recently regarding recursion. So I'm going to do a quick recursive solution, and then I'll do one without using recursion, just because, and you can watch whatever you want. So let's start with, in the recursive mindset, right? What do we need? Well, you need that base case, right? So you're always working towards the base case, or otherwise you don't really end, right? You just keep calling. It's like an infinite loop. So what's our base case here? Well, we're done when it says 1, right? So if n equals 1, return, and remember this is a string, right? They want the answer in a string. Simply return 1. Great. Okay, so what do you do in the other cases, the non-trivial case? Well, you're going to check for even and odd, and you should have that under your belt by now. If n modulo 2 equals 0, that means even, right? So I'm going to say return, and then we're going to add that arrow. So we'll say the current value of n, right? Because even the first one, 4, got included in the sequence. So let me do it this way. N, and then this arrow symbol that they use, plus Collatz, and remember the function, it was n over 2, right, when it was even. And there's only under one case, right? A number can only be either even or odd. So if we get down here and haven't returned, it's clearly odd. So we'll still print the current value and then set up the next value in the chain, Collatz. And if you remember, that was 3 times n plus 1. So I think this will cover us. We'll go ahead and test, and then we can even refactor that a little bit. Let's make sure we're on the right track. Looks good. Looks good. Okay, so I'll probably submit mine like this after I clean it up a bit. You could do it. This is plenty fine. This is condensed well, but we could do something like you can use that conditional operator right in here, right? You could go, if n is even, right, call it with this value, else it's odd, right, call it with this value. And then you kind of handle the even odd all in one go there. Ooh, there we go. So as long as I didn't type anything wrong, and it's up to you. If you think this is kind of alphabet soupy, you know, you don't have to cram it all in one line. Maybe you like that. I think it's okay. I think it's readable. So this is probably the one I will submit. And then, yeah, note for order of operations, right? I don't have to use parentheses here. Multiplication happens first, so I'm good there. If you're ever in doubt and you're not sure, don't feel like looking it up, you can always add them. It doesn't hurt anything, but you don't need them. So good. I'll hang on to this solution. Yeah, there's not much else to say. You can imagine as this thing executes, though, it gets that 3 value, right? So it sets up this string 3 arrow plus whatever downstream result is coming. You can imagine it kind of recursing down to the base case, and then the stack sort of unwinding and pushing the actual values in. So that's sort of how that works. I just want to keep up with recursion, keep you thinking about that, help you develop that. Good. So let's do it another way, in case you don't like recursion here. Or just to learn more. Why not? Learning's fun. Good. So we'll go, how about, we'll set up a loop here. We'll say while n is not equal to 1, right? Then we got work to do. Okay. So I'm going to calculate what the next value should be. I'll call it next, and we can say, I'll use this same conditional operator statement here just to get the appropriate value, whether it's even or odd. We already talked about that. I assume you're comfortable with that now. So we have the next value, and what we want to do is we're going to build, I'll call it result like I normally do, and initially it's going to be n to string, right? That was that first value we're given. It was the 3 or the 4 over here, right? So that's part of the chain, so we just pop that in. We get into our while loop, and while we're in here now, we'll keep sort of building on this, right? And so we'll add our arrow, and then we'll add the next value to string, right? We're doing our result in strings. And then the important part is, just like with recursion, you know, you got to work towards that base case kind of thing. We don't want an infinite while loop. We got to update n. So just set n equal to next, right? And finally, once you've done all that, you should be clear to return the result. And I'll hit the test. Green is gold. Green is the new gold. There you go. So another pretty concise solution there. I'm gonna go with my first one, but just wanted to show you there's more than one way to skin a cat, right? So I'm just gonna delete all this. You should have had time to pause it by now if you wanted to look at that. And I'll do recursion. There we go. They're going to make me run it again. That's okay. Yeah, I'll submit mine like this. I think that's pretty clear. And I wanted to point out, look at this. I went over 1,000 on my honor points. So I thought that was kind of cool. That's a cool landmark. Let me know where you're at in the comments, you know, how many you've been racking up, and we'll keep pushing each other, trying to get higher. I'm gonna submit mine. Got those points. So yeah, that's cool. I use join to sort of populate the arrow characters, and then you can just make just the collection of values in the sequence, right? And then join them with an arrow. That's cool. Good solution. So good stuff. See if there's anything else you can pick up in there. Otherwise, yeah, let me know what you came up with. Very curious to see how people in general are coming along with the honor points. I hope you're really growing there too. Otherwise, I'll see you in another video. As usual, thank you for watching.